right, so the next parameter we're going to look at today is parameter B. Now, parameter B does exactly what you've learned in the past. What happens when you change B is you get a horizontal reflection or horizontal stretch. Now, that stretch factor was not just B, but your stretch factor was always equal to 1 over B. So that's why your B value was so tricky in the past, is because you had to take the reciprocal to find your stretch factor. So I'm going to show you today what happens when you change B when it comes to sinusoidal functions. We're going to use y is equal to sine x as an example again. So go into your calculator and plug in y is equal to sine of x. So that's the original graph, but now we're going to apply a horizontal stretch. Instead of your b value being equal to 1, let your b value be equal to 2 now. So graph y is equal to 2x, and what I suggest you do so you can see what happens here in this graph is make your transform function look a little thicker. So go all the way to the left and press enter. Now use a zoom 7 trig window, and we're going to do this in degree mode, okay? So here is your graph, and there is the transform graph. So as you can see here, there's a lot going on. So right now I'm actually going to take the time to color code these two graphs. So I'm going to pause this podcast for a little bit and just give me. All right, so now my two curves are color-coded. So my green graph represents the original function, which is y is equal to sine x, and my red curve represents the transform function, y is equal to sine 2 times x. So let's observe these two graphs here. Notice that the amplitude did not change. So my amplitude is constant throughout. It still stayed as 1. But what did change here are your x-intercepts. Okay, so if I look at the green curve, let's identify the first positive point of intersection, 0. So that point of intersection is 180 degrees. Okay, now I want to see, where did this point of intersection go on my transform graph? Well, that was the first 0. The first 0 on the transform function is right there. So that's actually half of 180, which is 90 degrees. So all my x values got halved. And remember, the b value is still the same for this unit. What happens is that it got stretched, horizontally stretched by a factor of 1/2. So all my x values are multiplied by 1/2. Okay? It also changed one other thing. It changed the period of the original graph. So if you take a look at the original graph, which is the green curve, this is a sinusoidal wave. So the sinusoidal wave has a period of 360 degrees. So my period of the original function is 360. But on the transform function, it's not the same case. It went from 0, the starting point. Now this time, it starts repeating itself after 180 degrees. So my period went from 360 degrees to 180. So my period got halved. Okay, so to sum this all up here, I'm going to go to my other slide here. So what can we conclude about parameter B? B is the same thing as what you've learned before. B causes a horizontal stretch by a factor of 1 over B. Okay, when B is less than 0, there is a horizontal reflection in the y-axis. And then finally, here's the main thing right here. Because we are working with sinusoidal graphs, your period becomes 360 over B, or depending on if you're in degree, if you're working with degrees or in radians, it's 2 pi over B. Okay, so if I take a look at this graph, y is equal to cos of 3x, my period is 2 pi, or because I'm working in radians here, it's 2 pi over the B value, so it's 3. Okay, so that's my period. Okay, and of course my stretch factor is the reciprocal of the b value, which is 1 over 3. Okay, so that concludes my lesson on the effect of parameter b on sinusoidal functions.